This is the video for Mod 7 Lesson 6, Inequalities in one triangle. The goal of this lesson is going to be to determine side and angle relationships for within a triangle, and to use the triangle inequality to find restrictions on sides. So there are some theorems that we look at to see how the relationship between sides and angles of a triangle. So one we're going to see is if two sides of a triangle are not congruent. A big one is the largest angle will lie opposite the longest side. And the converse of that is also true. So when a triangle is put together, the longest side will always be opposite the larger angle. That is also true for the smallest side and the smallest angle, and vice versa. One thing you want to keep in mind, certain restrictions. We're going to talk about side restrictions later in the video, but remember the sum of the angles of a triangle is always 180, but that doesn't apply to sides, right? If you add up sides, that's a perimeter. So perimeters don't need to be 180, only the sum of the angles is 180. So, for example, for this problem, if I have that angle D is my smallest angle, the side across or opposite is my smallest side. So EF is actually my smallest side. 60 is my second largest angle. So the side opposite or across is DE. And maybe I put M for my middle length, M, small, medium, and long or large. And then my largest angle is 88, so opposite would be DF, and that's my longest side. So if I want to go ahead and write this out, my smallest would be EF, or FE, followed by DF or FD, and then followed by DE or ED. You can write the segment just naming with the endpoints, but it can go in any order. Same thing is true for the angles, or for the sides in relation to the angles. So my shortest side is 6, or AB. The angle opposite is C, so that's my smallest angle. My second, and if I go in numerical order, 10 is the middle length. So the angle opposite is A. I'm going to put M for my middle length maybe. And then the longest is actually AC. So that pairs with B, or the largest angle. So if I write this out, angle C was the smallest. Then and the inequality sign and angle signs kind of look the same, but angle C. And then it would be followed by angle A. And then angle B. In the second example, you're asked to list the angles and sides of the triangle in order from smallest to largest. So the first thing we can do is just identify the lengths or measurements were given, and then put those in order. And we know the corresponding side or the opposite sides are going to go in that same order. So for example, for number 1, our smallest side has a length of 2. I'm going to write S for 2. And I know the angle opposite is angle Q, and that's going to be our smallest angle. The second shortest side is going to be 5, because 5 is smaller than 6. I'm going to call this like the medium length or middle length. The opposite angle with that is going to be angle P. And then our longest side is going to be 6. And the opposite of that would be angle P, right? So if I'm going to list the angles and sides from order from smallest to largest, for the sides, the smallest we said was RP. We then said it was PQ. Or QP, same thing, and then QR. If I do the angles now, the smallest angle we said was angle Q. Then it would be followed by angle R, and finally by angle P. and this would be your final answer. For the next example, it's very, very similar. The only thing different is they gave you two angles, 43 and 98. We don't have angle S, but we can use the third angle theorem or the sum of interior angles to find what that angle is. So I'm going to add these up. So 98 plus 43. I know if I subtract that from 180 degrees, so if I go ahead and add those up, I'm going to get 141. And if I subtract 180 from 141, because the whole sum has to be 180, I get 39. So angle S is actually 39 degrees. So now if I go ahead and put these in order, my smallest angle is angle S. And my smallest side is opposite, which is TU, or UT. For the middle length, I can see my 48 is the second smallest, or the second largest, or the middle one. So that's 43. So that would be angle U. That's opposite TS. And then finally the last one, I'm left with angle T, which is across from US. And so this would be our final answer in order from smallest to largest. The second topic here is the triangle inequality. And so what this says is, if you pick any three sides, that doesn't mean it'll necessarily make a triangle. There are certain restrictions in order for three sides to form a triangle. So what this says is the sum of the lengths of any two sides must be greater than the third length. If I was to add side A and side B, the length has to be greater than side C, otherwise it won't fit together to make a triangle. Same thing if I take any combination like side A and side C, it must add up to be greater than side B, and same for the last combination. So any two sides I add up have to be greater than the third side, otherwise the side, it won't meet up and it won't create a triangle. So for the first example, we're given here three sides, 13, 15, and 9. And so I'm just going to sketch a triangle. I don't know if this is going to make a triangle, but I'm just going to name these sides just so we can visually see what's happening here. And let's say, so I have 13, 9, and 15. What they're saying is if I add up any two sides, so if I add up, let's say 9 and 15 and 9, it must be greater than 13. Same idea, if I add up 13 and 9, it must be greater than 15. And then the last one, if I add up 15 and 13, it must be greater than 9. So a few things you might kind of notice here. In the first one, you can see I'm adding up 15 and 9, but 15 is already bigger than 13. So we pretty much know that one's going to check out because we're already adding something that's larger than the third side. If I add up, same thing with 15 and 13 are already bigger than 9, so it makes sense that when I add them up, I'm going to get something larger than 9. The one you always want to check is if the two smaller sides add up to be bigger than the longest side, because that's usually where if it doesn't work, you'll have something that doesn't check out. So 13 plus 9 is 24. 24 actually is greater than 15. So this does satisfy the triangle inequality. So you would say yes, the lengths form a triangle. And that would be your answer. For the last example, again, same idea. I have a length of 12 and 10. I actually don't know what the third side is. I'm going to call it X. So we know there's some sort of restriction that we need to find, and we can use the triangle inequality to do that. So if I follow the same process as when it was three lengths given to us, if I add up any two sides, it needs to be bigger than the third side. So if I add up 12 and 10, it has to be bigger than X. if I add up 10 and x, it has to be bigger than 12. And then the last one, if I add up 12 in x, it has to be bigger than 10. So now if we go ahead and solve this out, when we solve it, we get this to be 22 is greater than x. We get this one when I subtract it and solve, x is greater than 2. And then this last one, we get x is greater than -2, but x is a length, so we can't have negative lengths anyways. We can't have -1 or 0, so I know this, the negative one, I'm going to throw out. So this is actually our inequality. So if I was to graph it, really what's happening here is I know, and this is the same as x less than 22. So really what ends up happening is I'm looking for numbers that are between 2 and 22. And so I can write this as a compound inequality if I want to, and this goes from 2 to 22. And that would be my final answer. So the range of values is between 2 and 22. If you have questions, make sure you are trying the U-Try problems and then asking for help during class, signing up for T-Bolt time, or getting help in the center.